Okay, this is screencast 4, the method of undetermined coefficients. So a quick breakdown of what we're going to be doing is we're going to try to solve a non-homogeneous differential equation with constant coefficients y prime prime plus p of t y prime t plus q of t y equals gt. That's a standard non-homogeneous ODE form. So we're going to guess a particular solution that has the same form as g of t, and then we're going to plug in the values of the coefficients that make this guess work. So that's the way how we're going to try to set it up. So step one, you're going to solve the non-homogeneous differential equation. Its solution is going to be yc, the complementary function. Then you're going to make a guess for that particular solution, yp. And then you're going to add the particular solution to the complementary, and it's going to look like this to get the general solution where you have the complementary solution and the particular solution. So remember, the complementary equation is going to equal 0, and the particular equation is going to equal g of t. And this makes it work out to the general solution because 0 plus g of t equals g of t. So with this example, y prime prime minus 4y prime minus 12y equals 3 times e to the 5 times t. So this is an exponential example. So we're going to follow the steps in the first where we're going to find the complementary equation, and then we're going to find the particular, and then we're going to add them. So with the complementary, the first thing you need to do is you need to find the roots. So you got to convert the equation where y prime prime is going to equal r squared, 4y prime is going to equal negative 4r minus 12y, which is going to be minus 12 equals 0. So then you just factor them out, and then you get your roots, negative 2 and 6. And so then you plug those in to the complementary equation. Y c of t equals c1 e to the negative 2t plus c2 e to the 6t. So C1 and C2 are just arbitrary constants, but you have your roots as your exponents, negative 2t and 6t. So this is what your complementary is going to look like. So with a particular, you're going to have y of t equals a times e to the 5t. So why do we have a e to the 5t? Well, this is going to be a guess, your guess, because the equation equals 3 times e to the 5t. So a is going to be your constant. That's what replaces 3. And then we're going to get a e to the st as our plug-in value because we keep that e to the, I'm sorry, not st, 5t, e to the 5t as our plug-in value. So when you take this value, you're going to also take the first and second derivatives and plug them in. So y is a e to the 5t equals y prime t equals 5ae to the 5t. And then y prime prime is going to be 25ae to the 5t. So then you're going to set all this equal to 3e to the power of 5t, or g of t. So you take that all and then you set it equal to 3e to the 5t, and then you do the math, algebra, and then you get negative 7ae to the 5t equals 3e to the 5t, and then you get a equals negative 3 over 7. So 3 over 7 is what makes this equal to 0, and that's what we want in the first part. Remember, we want to get 0 plus g of t equals g of t. So this is going to get you to g of t. So y particular t equals negative 3 over 7 e to the 5t. This is going to be your g of t. So then you're just going to add the complementary and the particular, and then you're going to get a yt equals c1 e to the negative 2t plus c2 e to the 6t plus 3 over 7 e to the 5t. So that is how you would get your general solution to a non-homogeneous differential equation. So again, the key things that you need to remember is that once you find your roots for your complementary, that gives you your complementary equation. And then the particular, the key thing is that you're going to be doing guesswork. Now this one was a fairly easy example. We had a 3 times e to the 5t. So your coefficient is going to be a, and then you have e to the 5t. And then you're going to take the first and second derivatives. then you plug them in, and remember, again, you want to get the particular to equal g of t, because the complementary equals 0, and the particular equals g of t. 0 plus g of t equals g of t. It's like y2 minus y1 equals y1. So, and remember, when it comes to the like the homework question that we did for number 3 with a particular solution for a sinusoidal equation, you're going to just take the first and second derivatives of that equation with the trigonometry, and then that's going to be really messy. And then you're going to plug that into the original, and then when you simplify it, you need to do your coefficient of line terms in order to get your coefficients for the complement for the particular. So 4a equals 3, then that means a equals 3 over 4, negative 4b equals 2, so b equals negative 2 over 4 equals negative 1 over 2. And so that's how you would plug that in your particular for this number 3 equation. So that's been my breakdown of how I do the method of undetermined coefficients. Again, it's a really standard way to solve a non-homogeneous differential equations, and it has a set group of steps that are, there's a lot of, it reduces it to where you can find a general solution by just doing algebra if you follow the steps properly by getting the complementary solution and then your particular solution. And it works, again, because the complementary equals 0 and the particular equals gt, so 0 plus g of t equals g of t. So I hope this helps.